Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. My name is Nurfatin Izzati binti Fairuz, and in this video I will share to you guys about magnetic field due to current. What will we learn in this topic? There are three subtopics that we'll read through in this video. The first one is magnetic field in two parallel wires. Second, magnetic field in a solenoid. And lastly, magnetic field in a long straight wire. Let's see some additional notes. For magnetic force, if they have different poles, they will attract. If they have same poles, they will repulse. For magnetic field, there are two poles, south and north. Then we move to magnetic flux. Magnetic flux is a number of magnetic field lines, and the symbol is phi. Magnetic flux is a scalar quantity, and they use Weber for SI unit. Formula magnetic flux is equal to magnetic field times vector area. Last additional notes is magnetic flux density. B equal to flux over area, where B in Tesla. The first subtopic that we will learn is magnetic field of a long straight wire. In this subtopic, we will learn about how to determine magnetic field direction in a long straight wire using a special rules. The objective is to determine the direction of magnetic field. But how to solve it? Well, we will using right hand rule. First, with your right hand, point your thumb in the direction of the current. Then, when you curl your fingers, actually, they curl in the direction of the magnetic field. So, that's how you determine the direction of the magnetic field in a long straight wire. So, in order to find magnetic field in a long straight wire, we can use formula B equal to mu naught I over 2 pi r, where B is magnetic field and the unit is Tesla. Mu naught is permeability of free space equal to 4 pi times 10 to the power negative 7. I is current over 2 pi r, where r is radius. Make sure your answer in Tesla. The second subtopic is magnetic field in two parallel wires. In this subtopic, we will learn about how to determine magnetic field if there are two wires, and how to calculate the force on wire that will produce. In order to find magnetic field in a two parallel wires, we can use formula B1 equal to mu naught I1 per 2 pi d. It is formula to find magnetic field in Y1. Then there will a force that will produce in wire 2, which we can find in using formula F2 equal to mu naught I1 I2 over 2 pi d times length wire 2. What can you understand through this picture? Actually, this picture is telling us that if there are two parallel wires and have same current direction, the force will not repel. But if two parallel wires that have different direction of current, the force will repel. In this video, I will share to you guys how to determine the force direction. So in this picture, we have two parallel wires that have same direction of current. So in order to find the magnetic field direction, we will use right hand rule. So this is current is going upward, and this is magnetic field direction. So the magnetic field here is going out from the paper. We will use circle, and this part is going into the paper. We will use X. Same goes to the second wire. So in order to find the force, we will use Fleming right hand rule like this. So make sure these two is perpendicular. This is force, this is current, and this is magnetic field. So in wire 2, we will use the magnetic field direction from wire 1, from this part, because the wire 2 is experiencing magnetic field by wire 1. So like this. So the magnetic field, the experience by 2 excited by 1 is going into, so the magnetic field going into, the current is going upward, and the force is going inward. That's why we will say that force experienced by 2 excited by 1 is going inward. Same goes with wire 1. Wire 1, the force is, where we'll use this part, this magnetic field that produced by wire 2 is going outward. It's going outward, and the current is going upward. So the force is going inward. That's why we will say that force that experienced by 1 excited by 2 is going inward too. The last subtopic in this chapter is magnetic field of a solenoid. In this subtopic, we will learn about what is solenoid, then what formula that will we use to find the magnetic field, and difference between magnetic field inside solenoid and outside the solenoid. Before we proceed with magnetic field in a solenoid, actually what is solenoid? Basically, solenoid is a long wire wound into helix. And the important things about solenoid is it will behave like a magnet when an electric current flows through it. Additional note about ideal solenoid. Ideal solenoid is a solenoid where the loops close together and the length is much longer than radius. Straight long wire is spun into a coil of several closely spaced loops and will produce electromagnet. Field lines inside the solenoid is nearly parallel, uniformly spaced, and close together. In order to find magnetic field in the solenoid, we will use formula B equal to mu naught times N times I, where B is magnetic field in Tesla, mu naught is 4 pi times 10 to the power of negative 7, N is number of loops per meter, and I is current. Now let's discuss about the difference between magnetic field inside solenoid and magnetic field outside the solenoid. Magnetic field inside solenoid, they are strong and approximately uniform, but magnetic field outside solenoid is very weak, non-uniform, and opposite direction to the field in solenoid. That's all from me. I hope you will gain some knowledge through this video. That's all from me. Thank you.